Okay, 12s, I need to restart this because I was disturbed by something. But in simple sense, let's just go back and analyze what we would have done so far here. So we had the equation that is at equilibrium, that is your chromate reacting with the acid and then producing a dichromate plus a water molecule. So what we've done is we've now taken the information to the table, what is given to us, because if we look at the statement, especially 6.4, it's 11 mole of chromate in aqueous reacting with X moles of hydrogen ions in aqueous. Then it says I initially added together to make a 0.5 cubic decimeter solution and allowed to react. Then it says the following, that when the reaction reaches equilibrium, the solution contains 9 mole of cubic decimeters of dichromate. Now that is the concentration of this, which of course I indicated that when we work in this, we have to convert that. So starting our table, we write down our ratio, we make the correct blocks, and then from there we have the mole ratio here. Remember, the mole ratio is interpreted from the actual equation. So the 2 was taken from the in front of this, the 2 in front of hydrogen ions, and then the 1 in front of the dichromate, and then the 1 in front of water. And when we move on with this, you see that we have initial moles, and this is given, of course, on the statement. We are aware that when we solve chemical equilibrium or KC problems, the product it does not coexist with the reactant. So reactants must be used first before we can achieve the product. Now, in this case, we then have initial mole, so which is 11 mole of the chromate, and then X mole of the dichromate. Then the change, right, refers to used and produced. So in this case, that is the block, and then equilibrium moles, moles at equilibrium concentration. So if you look here at the bottom, you'll see that I've substituted the 9, which was given as the concentration of the dichromate. Now we need to convert this 9 because we need moles at equilibrium for this. So what I've done is I've actually applied the equation. C is equal to N over V, and then it's 9, substitute 9, and then it's N over 0.5, which is the volume. When you multiply those two, you are actually getting 4.5, which is now substituted in the table. Now it makes sense to me that 4.5 will remain at equilibrium, so therefore those moles should be the same as the moles produced. Now we need to work backwards in this column to get the moles used for hydrogen ions and the moles used for the chromate. Now it's very simple. So we're moving from 1 mole. If we look at the ratio, we're moving from 1 mole to 2 mole, 1 mole to 2 mole as well. So we expect that the ratio should be 2:1 or 1:2 because we're reversing this. So when the ratio is 1:2, it simply means that 4.5 therefore becomes 9. So then it simply means that here we are going to have 9. Remember, it's the ratio 1:2, so which means that for every 1 mole of this, then we have 9 moles of the hydrogen ions. So it's 4.5 times 2. That's what 1:2 means. Then this one is also 9 as well. Now, then of course we need to work this out to get the moles at equilibrium. If we touch our calculator again here, you will see that will then be 11 minus 9, which will give us a 2 in this case. And then the other one, of course, it's X minus 9. So that's basically how it's done. Then the last part of this, we now are going to use the same formula that I've used here, which is a C equals N over V. We now are looking for the remainder of the concentrations. Now we are going to, of course, do the division. Once again, we're looking for concentration. So C is N over V. So in this case, we have 2 divided by 0.5. Right, so If we punch our calculator, just to make sure we're accurate, 2 divided by 0.5 will give us a 4. So this is a 4. Now this one will have to be worked out, because if you look at it, you will see it will say here x minus 9, then divide by half. Okay, we have to work it out. So if you are to work this out, it will be x minus 9 over, oh, not over, let me not use that, okay, over 1, and then from there it will be times 2 over 1. Now that is going to be 2x minus 18. So that's what we're going to have. So for me here, we're going to have 2x minus 18. So that's how you solve this. Now from here, we need to go and solve for the KC. Now I just want to see if I can squeeze it inside the space here. So KC, of course, is, we take it from the equation there above, CR207 2 minus raised to 1 divided by the reactants. In this case, it's a CR04 2 minus raised to 2, and then the other one is hydrogen ion raised to 2 as well. Then it's a matter of substitution. The equilibrium constant is given, so you substitute that one is a 0.09, and then from there we substitute the rest of the numbers, which of course in this case are concentrations. And then this is a 9, right? And then bottom here we substitute. Here we have what? This is a 4 raised to 2, and this is a 2x minus 18, then raised to, this should still be divided by 0.5 since it was LCD, and then raised to a square. Is it a square? Yes, it is a square. Okay, then you can solve it from there.